4-2 integer patterns. I can solve operations with negative exponents and 0.
All right, so we are now capable of solving operations with negative exponents and 0, yes or no?
Yes.
Integer and exponent would just be a review. We didn't even do a cheat sheet because those are words that we should be well aware of. Number 2, patterns of exponents, problem 3. This is a pretty valuable problem as far as proving that exponents definitely follow a pattern. If you'll recall this problem, we actually started over here with 2 to the 3rd. You guys told me it was what?
8.
And then I dropped 1 power to 2 to the 2nd. You guys told me it was?
4.
And then I dropped another power, and you guys told me it was?
2.
And then I dropped another power, which brought us to the power of 0, and you told me the answer was? 1. And the reason we were able to come up with 1 is because you realized that all of our evaluations here, we were dividing by our base. And our base is what? 2. So what's 8 divided by 2? Everybody.
4.
What's 4 divided by 2?
2.
What's 2 divided by 2?
1.
1. And then we started dealing with negative exponents. So we went to 2 to the negative 1 because that's the next logical integer exponent. And what is 1 divided by 2? 1 divided by 2 is 1/2, right? Because 1 divided by... What am I doing here? 1 divided by 2? It's 0.5, yes, no? Okay. And then we divided by 2 to get to 1/4, right? So we've got 1/4 divided by 2. Do you ever divide fractions then?
No.
And we said, well, 1/4 divided by 2 is 1/4 times 2 over 1, right? Which is equal to 2/4, which is equal to... What did I do wrong there?
Oh, you have to switch.
Oh, I didn't switch it. This is 1 over 2. So this is 2, 1 over... Let's do that again. Sorry about that. So 1/4 divided by 2. Went too fast. When dividing fractions? So that's a 2 over 1. So it's 1/4 times 1 over 2, which is equal to 1 over... Oh, I skipped the 1/2. No, I did. Yes, I did. I started with 1/4 here. I should have started with 1/2, right? So 1/2 divided by 2 is 1/4. You get the idea, right? Okay, my bad. Moving on. Number 5 and 6 would just be using exponents. Pretty self-explanatory. 7 is your rule. Applying negative exponents was just some practice. I don't think we need to spend a lot of time. Other than if you have a negative base and you flip it, so the negative 7 got flipped to the bottom because we had a negative exponent, does the base remain negative or does it go to positive? It remains negative. Don't get that confused with the exponent. The exponent here became positive, but the base obviously is going to stay negative. And then the last one, I'm sorry, this isn't the last one. We talked about 0 powers, and again, we used patterns to prove 0 powers, which I just showed you up above. And then the last one, we just gave you this big, huge problem with negative exponents and 0 powers, and you decided that you needed to do what to solve this? What do you need to do to solve this? Anna? Use PEMDAS. Obviously, use PEMDAS. You have to use PEMDAS, but the strategy while using PEMDAS, Anna, is what? Don't combine your steps, otherwise you're going to probably mess something up. The answer, 5 3/4. Be careful down here. We're still making this mistake where are we subtracting 1/4 first, or are we adding 1/4 and 1 first? Okay, remember, subtraction and addition are the same, so you go left to right on those when working with PEMDAS.